Thanks to the organizers for giving us the opportunity to speak on this topic. If anyone's feeling hungover or not quite there or feeling sick, just note that the nearest exit may be behind you. So, quick introduction, my name's Felix. I'm a principal consultant at ThoughtWorks. If you've never heard of ThoughtWorks, we're a technology consultancy, and we're basically putting together strategy, design, and software engineering. We're putting them into bespoke solutions for clients that solve interesting problems. I'm an engineer by trade. I've spent many moons in the InfoSec space, and I've led the ThoughtWorks cybersecurity team for some of that time. And at this point...
Hi, everyone. I'm Nazneen. I've been with ThoughtWorks for 12 years. Currently spearheading the threat assessment and security engineering stream of work within the InfoSec department. Prior to this, within the security domain, I have led and set up the AppSec program for ThoughtWorks internal operations. That was the talk I gave last year, too. So I'm really excited to be here.
All right, so today we're going to talk about the challenges imposed onto a vulnerability management program by the sheer scale and rate of change of a technology estate. We're going to relive some key decisions and lessons learned on our journey to building something on that, building a vulnerability management program and building a robust, scalable, and automated security framework to actually improve your security posture. We're going to talk about vast technology estates and how that changes how one might approach this. We're going to talk about how autonomous teams come into here and the competing priorities that they might have, and that, well, the challenges that this imposes when you're actually trying to make them do something.
Coming from a developer background, vulnerability management has been quite new, but a fascinating journey for me. It has been eye-opening to see how quickly new vulnerabilities emerge and challenge our best efforts to, secure our systems. But before I delve into the challenges, let's get a quick sense of the room. How many of you all here are either subjected to, contributing to, or even leading vulnerability management efforts? Could you raise your hands? Okay. Thank you.
Keep them up. For those that have them up, keep them up.
Yeah, please keep your hands up. For all the hands that are up, how many of you all believe that the program is tackling the right problems or tackling the right problems and creating a significant positive impact towards your company? That's amazing for the folks who still have their hands up. We would love to exchange notes and hear about your approaches too. Feel free to put your hands down. Thank you very much. For the rest of the folks who are unsure of all the alerts coming your way, or are here to understand how to enhance your vulnerability management program, or even yet to embark on this journey, we believe this talk will bring a different perspective to this topic when we share the technologies and the efforts that underpinned this transformation we underwent. So with that, let's start by understanding what a vulnerability management program entails. Usually, the responses people hear, read, it's like this program is all about fixing security holes. It's about patching. It's about a tool that runs in an automated fashion to detect vulnerabilities, detect issues. So overall, it's about continuous assessment, scanning, and remediation. And yeah, that's quite concise. That quite sums it up. So let's look at the life cycle. So usually, a product is developed, it's deployed. Then there is a scanner that looks at vulnerabilities in probably dependencies, so it scans a log file, or a agent scans a host. Then there could be a ticket. There will be a ticket that is generated if there is a critical or high severity vulnerability. And then an alert is sent to the team with a predefined time to state this is when, or this is the period in which you should fix this vulnerability. So there's a lot of effort in this, in this process. And the question that keeps coming back is, despite all these efforts, is the security posture changing in a meaningful manner? In fact, developers frown upon this because the number of overwhelming alerts that come their way without business context is difficult to shift through. And at the same time, security consultants who, for a very good reason, view the weakest link as a potential breach, find the continuous follow-ups quite mundane and repetitive. So overall, there's a lot of ambiguity, a lot of frustration, a lot of blame game, a lot of confusion on what to do. So let's base our conversations on some data. Don't worry about the tiny numbers, I'll speak to it, but just let your eyes go out of focus and look at the shape of the graph. This is talking about the number of vulnerabilities that were disclosed per year. In 2023, about 26,000 vulnerabilities were disclosed. It surpassed the number by 1,500 in 2022. So every year, there are more vulnerabilities. Oh, I missed a point. Oh, it's going ahead.
Sorry.
Can you go to the previous slide?
Yeah.
Thank you. So despite these number of vulnerabilities, CSPM tools do generate a number of alerts, which basically are talking about, these alerts are like any misconfiguration, which is away from your best practices or regulatory compliance, that is also generating alert for your team. So the number of vulnerabilities disclosed are sending alerts to your team, as well as CSPM tools are generating alerts. So a lot of alerts are coming towards your team. The clicker. Thank you. Oh, I'll keep it okay. So apart from the number of alerts that are increasing, the number of breaches are also high. Despite all the security tooling, the number of breaches are at an all-time high. Let's take 5 seconds to read through this data. The number or the data that stands out the most is the cost of a data breach. At the same time, if you see 80% of the organizations have faced an incident due to cloud misconfiguration. And previously, as I was saying, CSPM tools generate a number of alerts. And it's quite possible that actual attackable flows in the cloud infrastructure get lost because of the flurry of alerts. To me, this data, or the persistent high number of breaches, calls out that there is some inefficacy in the current alerting, detection, and remediation systems. If we are not going to make a change, we are going to face a lot of consequences. In fact, a number of enterprises, the breaches have cost a number of enterprises a fortune. And here is an incomplete sample of a few. The links to these breaches are listed towards the end of the deck for reference. But overall, this is how Qualys sums up this issue. If everything is critical, nothing is. And the report from Qualys states that out of all the disclosed vulnerabilities, only 1% was related to a significant high risk and was exploited in the wild. Only 1%. So let's sum up our observations that led to the transformation. The barrage of alerts towards the development teams led to alert fatigue and made the teams insensitive to real threats. Not all severities are created equally. It is very difficult to gauge the severity of vulnerabilities without business context. You may be very happy going to talk to a team to say, oh, you know what, there's an SSHD vulnerability because it has remote code execution. But that's on a container that is short-lived, running a trivial management report, as well as a container does not have any ports open to the internet. Is that really critical in that case? Is the likelihood high there? We ended up using a ticketing system that suited us, suited the tech security team, and it was not helpful for the delivery teams, which increased the communication barriers. The number of tools, the number of multiple tools we used, which were very specialized for their security scanning, created a fragmented view. There was no way to stitch up the alerts. There was no way, or there was no one view to understand where action is required. In fact, a lack of single pane of glass also created an issue for the analysts, for the security analysts. The manual follow-ups when your operations are scaling is impractical. You cannot work with a spreadsheet or Excel sheet to say, now who's the infra owner? Is this team disbanded? If this team is disbanded, who do we escalate to? It is not going to scale with scaling operations. And towards the end, you will not end up looking at the real threats. While working on an SSHD with remote code execution on a short-lived container, a cookie is exposed that will exfiltrate your data, which was missed because our tools don't catch such kind of issues. So the traditional methodology of looking at number of vulnerabilities is a metric. We should look at number of vulnerabilities. Does not work, did not work for us. We found it ineffective. So something had to change, and that is where I hand it over to Felix to talk about the how.
Thank you very much. So what do we really need to know about in order to build an effective vulnerability management program? All right, let's start with knowing the technology estate's footprint. You need to know the kind of things that you should be defending. You need to figure out a way to mitigate security debt or tech debt. There is no real difference between those two. I'm going to use those two expressions interchangeably. Then you need to figure out of all the things that could potentially go wrong, and which ones actually present a problem to you. And then, no vulnerability management effort is complete without going on the offensive and really poking at your systems and finding the hidden problems that only really present themselves when someone's actively looking at them. Cool. Let's talk about the footprint of the technology estate. So I had an embarrassing moment a while back. So my CISO approached me, and he said, I have this report from an external company. They had no knowledge of our internal systems, and they found a pretty big hole in our systems. Nothing critical for the business, but still it was some exploitable hole. And he was like, can you comment on that? And I really couldn't, because I was looking through our systems and we didn't even scan that thing. So the big lesson here is, please avoid opportunistic scanning. We ran into this problem because we put our scanners where it was easy to put our scanners. We had them in pipelines, we scanned some containers, we scanned some hosts, but there were a ton of hosts that we just didn't know about. Right? So we didn't actually bother scanning them. We never looked there. So opportunistic scanning is a problem for you. So you might ask, how do I actually get a view of my tech estate? How is that possible? So most in this room, you're engineers, right? You're going to have an inside-out view of your attack estate, which means you know where things are. You have all the knowledge of the attack estate, but the problem is you don't have the attacker's tools. And, well, some of you have, but most of you at the moment do not share their tools or are not experienced with them. So you have all the knowledge, none of the tools, and none of the priority, which things actually matter. Then there is an outside-in view of your attack estate, which is an attacker's view. They have no knowledge of where things are. They have all the tools to look for things, but they also have no prioritization. And then there's a third view you can adopt in order to look at your attack estate, which is existing threat models, which means go to your risk management department, adopt a business level view on things, and your risk management department, they likely have threat models, they likely have business level risks. They have no knowledge about the attack, of course. They have no knowledge about attackers' tools and attackers' views on their systems, but they have all the priority, all the things that matter to them if they break. So let yourself be inspired by these views, and then you can gauge the extent of your technology estate through questions. So in order to reach a robust understanding, here's things that you could ask yourself. How do systems in my technology estate interact amongst themselves? How do I reach across the boundaries of my tech estate? How are my employees connecting? Is there a VPN or something? How are systems networked? Where are my compute resources? Where is my data storage? Where is my data processing? Is there some form of structure that is underlying my tech estate? Are there physical assets? Are there non-computer assets in the tech estate that I need to know about? Is there like OT technology, like, I don't know, manufacturing robots or pipeline sensors or that sort of thing? Is there like IoT type of things like, you know, the Raspberry Pi that controls your meeting room, stuff like that? So those are, you know, questions that you can inquire into. And in the end, you're probably going to have a list of things like IP addresses, VPCs, DNS records, yada, 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 right? All the way down to like switches and sensors. Those are all things that you will have to include if you want to build an actual vulnerability management program for your company. So just be aware, you're probably going to miss some things. It's not the end of the world. Just let your mind be open. You're not going to catch everything, right? You're not going to be looking at everything. So, you know, be humble here. All right. If you're in the cloud, it's quite easy to discover the assets that you have via an API. If you're on-prem, it's slightly harder because you will have to discover from records that, you know, some Excel sheet or some manually written down thing that where someone has actually noted the subnets, right, or where the switches are, or passwords for the switches, or that sort of thing. And also be aware that if your technology estate is large enough, it will probably shift below your feet while you're standing on this. And so you have to automate to avoid that drift. You have to have, so if your system is actually, if your scanners are actually reaching into systems, just be aware that there's new systems coming online, old systems shutting down. So you will have to have sort of self-enrollment, self-deprovisioning. That has to happen automatically. You will have to have some form of drift correction. Maybe someone is deleting a role from an AWS account that you rely on in order to actually, you know, assume into that AWS account. So self-healing, drift correction, auto-enrollment, auto-deprovisioning are super, super important. Yet you will still have to do things manually. There will always be, you know, these 5 remaining % where you actually have to follow up on your own. Write playbooks for them, right? Because, you know, in order to also keep buzz factor low in your team, write down what you're actually doing. Set yourself alerts and reminders that you have to do these things. All right. At this point, we know how big our attack estate is. We know all the things that we should be scanning. Let's talk about, you know, mitigating tech debt. The first problem that you're going to have is you're going to have a lot of scanners out there, probably. Right? You have to kind of take their data and put it together. I really recommend avoiding like 10 different tools competing for your attention. Right? So take the data, put it together in some place in a common format to make sense of this. But the problem is that these findings alone really, without context, don't mean a lot, as Nazneen said. So you have to enrich them. Right? You have to give them context. You have to give them, if you present a developer with a finding, say, hey, we found an RCE on this host, and you just give them the host identifier, they're going to be like, cool, which AWS account, which region, which VPC, where is this thing? How do I find this? So you don't want to create more work for the teams downstream. Enrichment in general helps highlighting the things that matter, and it helps speed up fixing. You could use low-code tools like Tines, for example. We generally prefer AWS step functions, just because it's a very nice way to break down an enrichment pipeline for findings. It's very, very useful in that regard. A problem that is often overlooked, but is super critical, is how do I know who actually needs to fix this? How do I develop? How do I infer ownership? Right. So you need to have some form of register who owns what in your company, who owns AWS accounts, who owns switches, right? Who's responsible for an office? Who's responsible for hosts? That sort of thing. So you need to create some kind of register. It has to be up to date. But the more critical thing is it has to be kept up to date. And it has to be machine readable, because if you're going to go around and assign ownership by hand, you're just going to kill yourself with work. Right? The thing here is unassigned risk in such a thing is just worse than useless, because you've done all the work, but you're still not getting anything done. And as I said, manual follow-up is just going to kill you. So we have a finding, we've enriched it, we know who should fix it. Now we have to assign it to them. Right? We have to know them. We have to notify them somehow. Here, it's super important to keep in mind that this is a friendly process. Right? You don't want to be the security team that goes around and says, "This is shit. This is shit. This is shit." That's not how it works. Right? You want to be inviting the teams to collaboratively fix security issues in their system. So notify them in a friendly manner. Maybe notify them a second time in a friendly manner. And then if there is an escalation process, it's still a friendly process, right? So it doesn't help if you just become unfriendly. This is slightly hindered by the fact that a lot of companies have something like, you have 72 hours to fix high-end critical vulnerabilities. That's a complete anti-pattern. In fact, Google has, in their minimum viable security product, the MVSP, Google went away from this, you have 7 days to fix something, and they basically said you have 30 days to apply a patch and 90 days to develop a patch. It's a very different approach to how most companies handle vulnerabilities internally. The problem with this 72 or 24, 48 hours, however short, SLAs, is that if there is a potential problem, this is way too short for the team to actually prioritize this in their workflow and actually getting this done. And it's too short, it's way too long for other reasons that I'll get into later. So you're stuck in between 72 hours, way too long, way too short at the same time. Just keep it relevant for them, what you're notifying them on. Next thing, you have to track remediation. This is actually something that is not spoken a bit, not spoken enough about, because if you have a vulnerability, it represents risk. Risk has 4 different general ways to deal with it. You can avoid it, you can mitigate it, you can transfer it, and you can accept it. In the case of scanner findings, there is a 5th one, which is it's a false positive. Just ignore this. Transferring for vulnerabilities works only somewhat, but it's absolutely legitimate to accept the vulnerability. Right? If you're gonna say, like, I cannot fix this vulnerability right now because the operating system does not get updated, what are you gonna do with it? You can keep alerting them, but it's not gonna go anywhere. Mitigation, of course, that's what everyone wants to have, but avoiding is also possible. You can just say, like, I'm gonna decommission this system next week. I'm not gonna fix this vulnerability. You can notify me all you want, right? And in the end, please, if you build such a program, please track that the engagement that your teams have with this program. Make sure that this is actually being used. And make sure that it actually moves the needle. Find some form of proxy. For example, mean time to remediation or false positive rate or something. Make sure that you're actually getting something out of this. Well, we dove in head first, and we thought, how difficult can it possibly be to build something like this? The answer is very. And so there are, we started with like different scanners competing for our attention. And in the end, there are tools that show weaknesses better than others. And 10 different scanners that are not connected are typically not as good at showing weaknesses. And you have to stitch them together manually. But then there are tools that actually do this really well. And those are, I'm not sure if you've heard the name CNAP, Cloud Native Application Protection Platforms. It goes by different marketing names. Viz is one of those tools, Orca is one of those tools, there's Palo Alto's Prisma, and like different tools that you can use for this. What the industry has started to realize is that attack paths are more useful than CVEs. CVEs are potential risks, but CVEs is more kind of a thing like, if you have Dependabot or Renovate, you're good. Right? That's like the answer to most CVEs, just patch your stuff. Attack paths are different. They represent how different CVEs and infrastructure misconfigurations can actually be stitched together. It's still a theoretical, like inside-out view on your attack estate, so you're not going to have the attacker's prioritization for this, but it's vastly more useful and has way more context to things that actually can go wrong in your attack estate. So attack paths are better than CVEs. The next thing is, in your tool belt, there should be something that actually patrols the outside of your tech estate. So we adopted Shodan and Tenable. Shodan is a port scanner, and Tenable, I think most of you should be aware of the Nessus scanners. They scan the outside of our tech estate. And if something gets found there that is exploitable, your SLA of how long do I have to fix this should actually drop to 0, or like this should have been fixed yesterday. So in that case, the 72 hours are way too long that most companies have, because if you have an exploitable vulnerability, you have minutes, maybe hours, but definitely not more than 24 hours to fix this thing. So in that case, fix whatever is visible on the outside as soon as possible, right? Ideally, also conduct a threat hunt. But no vulnerability management program is complete without offensive security efforts, and at that point, I'm going to hand over to Nazneen.
Okay, thank you. As we worked on our security strategy, we understood that we had to evolve it from merely reacting to vulnerabilities. We cannot wait, or we decided not to wait for issues to arise, but actively seek them out through offensive security practices. Relying, or I must say, only relying on passive scanning can give a false sense of security. These tools tend to generate or tend to create vulnerabilities, alerts, based on predefined signatures and algorithms. They often miss the nuances of how these vulnerabilities can be exploited in a real-world context, in the context of your organization. A few of us got enthusiastic and curious to understand how do we really get to understand these vulnerabilities, how they're exploited in our context. So we proposed, let's start with the internal red team. And of course, like not with the right skills and with the priorities, that did not go far. So then we proposed, let's enhance our current vulnerability management process to understand what are the attack surfaces these scanners miss. And with that, we started focusing on active probing, and we encountered ways, or we looked at ways to understand how do we cover up, or how do we cover OIDC-based account takeovers, authentication bypass vulnerabilities, subdomain takeovers. Normally, these are not found by scanners, and it would not get covered if we were not looking at it from an offensive security lens. In fact, we went ahead to also understand what are the scanners that we can put in place to do active probing over the internet to see what kind of internal data is available publicly, or typo-squatted domains. So a few of us taking 2 hours in a week proposed this, and then we went ahead to see, adding it to the top of the pyramid, how can it benefit us? And we were quite amazed by the benefits. But apart from our team, the delivery teams also appreciated it. When the delivery teams could see an attack actually happen in a controlled manner, they could appreciate why this vulnerability should be fixed, or why are the analysts continuously following up. So being able to give the teams a list of vulnerabilities based on, not on a list of issues coming from a scanner, but based on the potential of the exploiters being able to be exploited was helpful for the teams. So in this case, we never waited only for outside in. We worked with the team saying, OK, let's work with the compromised credential and see where the impact is coming through. How are you able to exfiltrate data? How are we able to escalate privilege? And that is when they could see the need for layered defense, or as we say, defense in depth. So overall, it has been appreciated by the teams because we help them to make more informed decisions, reduce noise, but also increase the focus on critical issues that can hinder the security of the organization. Actually, one of the side effects for us is that we could also nicely see how our defenses are lined up against the MITRE attack framework, and it was a valuable bonus to us to get that visual too. I'm talking of the attack framework, so it's like talking it as an adversary, but seeing where our defenses are lined up. So that was quite good. So overall, our strategy, or overall our transformation worked towards auto-discovery, self-healing, self-enrollment, which helped us understand our tech estate better, as well as scale with our scaling operations. We worked towards reducing the cognitive load to look at various scanners by bringing a single pane of glass. We worked towards improving the communication by working on a system that worked for the delivery teams, because they have to respond to the vulnerabilities, so make it easier for them. We prioritize attack path analysis, which helped the teams to understand the impact better. And with active probing, we were able to help give the teams a list of prioritized vulnerabilities. And I guess, yeah, that's a wrap.
Cool. So thank you for being with us. If there is nothing else that you want to take away, let it be these 4 points. And with this, yeah, thanks for spending the time with us, and we're ready to take our questions. And here is how to reach us, over wherever you prefer to reach us. Thank you.